So are you ready to start proofs? Very exciting. You get to do your first proof tonight. Okay, we are on this page in your notes, which is using properties to justify equation solving. Before we get started, we have a few more properties that we're going to add to the list, and they might seem a little bit silly to you, but hopefully once we use them in our equation solving, you'll see how it works. You won't feel like it's so silly. All right, so the addition property says if I have two things that are equal, I can add something to both sides that is equal, and I'm not changing the value. So for instance, if we had an equation that said 2x minus 6 equals 10, I can add 6 to both sides, and that's not going to change the value of any of what was originally presented because I'm adding equal quantities to both sides. We used to say it was keeping the balance. Okay, so it's also legal to do that with subtraction. So if I had 2x plus 6 equals 10, I could then subtract 6 from both sides, and that's legal. The multiplication property allows me to multiply both sides of an equation by the same value and keep the balance. So for instance, all you fraction lovers, if you had 2/3 x equals 10, we would multiply by, bada bing, bada bang, 3/2, the multiplicative inverse. And multiplying both sides of an equation by the same thing is not going to upset anybody. All right, division, that's often our last step. Either one of those two is our last step in equation solving. That's going to let me divide both sides of an equation by a number. And the final one is symmetric, which we've already gone over. So let's say I've done a whole bunch of steps here and I get to 10 equals x. It allows me to then say x equals 10. So if 10 equals x, then x equals 10. Let's see how this works in a problem. So if we're going to look at this equation, the first step that we would want, oh, I need you to change one thing, sorry. Everybody right now, change this 15 to a 16. Trust me, you'll be a lot happier later on. All right. The first step in this equation, for most of us logical people, would be to distribute the 8. So I would get 7x minus 16 equals 48 plus 16x. And the reason for that is just the distributive property. And I'm not going to write property over and over again. I don't expect you to either. Now, our next step, some of you might have different opinions than others, but basically what I'm going to say is let's get rid of the 16. Bring it to the other side. Okay? So 7x minus 16 plus 16. We're adding 16 to both sides. It's kind of like you need to break this down into its real bare bones. Okay, so basically what did I do here? I added 16 to both sides of the equation. Now, I know a lot of you might skip this step, but if you're ever a teacher, you will know that you have to really explain that when you are teaching how to solve equations. So that is then the addition property that we just learned up above. Now, again, what happens here, I get 7x plus 0 equals, I'm going to write this out and you'll see why in a minute, plus 16x plus 16. And the reason for that is if you look at minus 16 plus 16, that's going to be additive inverse. That's how I got the 0. So it's like you're taking each step and you're explaining exactly what you did and why you did it. Okay, here on the left-hand side of the equation, you're actually performing what you did, and on the right hand, you're explaining why. So these are kind of like my steps, and these are kind of like my reasons. And you'll see that very often in geometric proofs, okay? And actually, I didn't explain the first thing there, but the first thing there, when they give you this, the reason is given. That's what I'm supposed to solve, so that's my given, okay? Now I get 7x equals, I'm going to keep this side the same again, 48 plus 16x, just so you can really see how it works step by step. And the reason for that is then additive identity. The next step is kind of interesting, and I think I'm going to spell it out for you just so that you can see exactly what I mean. 7x equals 40, well, let's do it this way. 7x equals 16x plus 48 plus 16. What property did I just use there? Your friend and mine. Good old commutative. Allows us to change the order. Once I do that, I get 7x equals 16, x plus 54. And when you don't really have a reason, all you're doing is computing, you just write simplification. If it's strictly simplification. If there's not really a reason and you're just kind of bringing a step down and simplifying it, okay? Now we technically have to move our variables to another to isolate them on one side. So I'm going to go 7x minus 16x equals 16x plus 54 minus 16x. And the reason for that is subtraction. Then I'm going to get negative 9x equals 16x, and you'll see what I can put these in one step, plus 54, because I'm going to kind of slash it out there. I'm going to say simplification for the left, because that's not really a big reason. Everybody can kind of understand that. And then on the right, it was commutative. No n, remember, in commutative. All right, and then we are going to do negative 9x equals 0 plus 54, and the reason for that is additive inverse. How we doing? We're getting there, trust me. And then negative 9x equals 54, and you should be well aware of what this is by now. That's additive identity. Okay, I'm going to divide negative 9 into both sides. So that is going to be division, and I can just kind of list it there where I put the denominator. Negative 9 divided by negative 9 is going to be 1x equals negative 6. And the reason for that, it's really simplification on the left, but on the right, excuse me, it's negative 6. On the left, if you think about that, that's really multiplicative inverse. Okay, something divided by itself or the reciprocal, something multiplied by the reciprocal. So this could be multiplicative inverse. And then you could write simplification for the right. And then x equals negative 6, and your reason is multiplicative identity. How we doing? Excellent. You're done. Woohoo, your first proof. All right, I'm going to go to the next page, and what I'd like you to do is pause, think about it, try it. This last one I'm going to let you do, or the last two on the page, B, and I think there's a courtesy of New York State Regents question down below. I would like you to do on your own for the rest of homework, but why don't you try 2A and then come back and you can check with me, okay? So I just wanted to get that written up there quickly so you don't have to wait for me to write it all out because you've done it already. So as your first step, you probably had distributive property, which is pretty straightforward. After that, it starts to get a little diverse. In other words, someone may have done a different step here than someone else. I chose to eliminate my constants first. You may have chose to move your variables first. So your reasons might be flip-flopped from mine or in different order, and that's perfectly fine. I decided to add 12 to both sides using the addition property. I got additive inverse because I got 0 here where the 12s canceled out, and then they just simplified on the other side. Then the 0 cancels out, so I just get 5x equals 3x plus 18, and that's additive identity. Then I subtracted 3x from both sides, and the reason for that was subtraction. I did a couple steps in one there, and that's pretty legal when it's something kind of minor. I'm just switching orders, especially using like commutative property. Commutative property and additive inverse I put in together, and there was just simplification on the left, so I really don't need to list that. Then I got 2x equals 18 by the additive identity, divided both sides by 2 using division property, and then the last step using multiplicative inverse and multiplicative identity, I got x, and I simplified getting 9. I just wrote that simplification. You need not have that. Okay, I just put it kind of actually really squeezed it in there. But that's basically the process. So I'd like you to do the next problem, and it does work out to be a fraction. Don't be scared. And then just the one from the New York State Regents test. Okay. So have fun. This is a challenge, but it's a good challenge. It gets your mind to really think step by step, logically and systematically. Have a great night, and I will see you on Monday.